Good evening to everyone. So, in this class, we will discuss some of the problems in Fourier transform. The first problem is find the Fourier transform of. Yesterday, we discussed find the Fourier transform of a square minus x square column. So, today we will discuss find the Fourier transform of find the Fourier transform of f of x is equal to a minus mod x. A minus mod x for mod x is less than a and is 0 for mod x greater than a greater than 0, and hence deduce that and hence deduce that first one, integral 0 to infinity sin t by t sin t by t whole square into dt. Second reduction 0 to infinity sin t by t whole power 4 into dt. Okay, so first we'll try to find the Fourier transform of f of x. Solution. So first step, we should write the definition of Fourier transform. For the Fourier transform of f of x is equal to 1 by root 2 pi minus infinity to plus infinity minus infinity plus infinity. F of x is what? A minus mod x. A minus mod x into e power isx into dx. Okay, and then we should write. We should divide the whole interval into yes. Actually, first step we should divide the whole interval into three parts. Okay, wow. I'll write here minus infinity to plus infinity. I don't write here a minus mod x. I just write f of x. Write just f of x and e power isx into dx. And then you need to divide the whole interval into three integral, as I told in the previous lectures, from minus infinity to where a minus infinity to 1 by root 2 pi. You should divide the whole interval into three parts, minus infinity to minus a. So in this interval, f of x is what? 0. Okay, so that's why I'll put directly 0. So 0 into dx, and then minus a2 plus a. So in this interval, what is f of x? A minus mod x. A minus mod x into e power isx into dx. The third integral also from where to where? The third integral a to infinity. So here also f of x is what? 0 into dx. So close the bracket. Okay. Now the next step, I'm going to write only the second integral. So which is equal to 1 by root 2 pi minus infinity minus a2 plus a minus mod x into e power isx is cos sx plus I sin sx into dx. Okay. So we know that mod x is an even function. So totally a minus mod x is even. This is what? Even. This is what? Odd. So the next step I am going to split into two integrals, which is equal to 1 by root 2 pi, 1 by root 2 pi into uh, minus a2 plus integral minus a2 plus a minus mod x into cos sx. Okay. And then plus I into integral minus a2 plus a minus mod x into sin sx into dx plus I into integral minus a2 plus a minus mod x into sin sx into dx. Close this bracket. Close this bracket. So now I told already the totally this is what? Even function. This is what? Even function. Even into even. Even. So this is what? Even function. This is odd. Even into odd. So minus a2 plus a odd integral na will get 0. The integral value is 0. Here minus a2 plus the integral is even. Now you can write 1 by root 2 pi 2 times, because this is an even function, that's why I'll write what? 2 times 0 to a. So in this interval, because the values are only positive, that's why you can directly write mod x is equal to x. Mod x is equal to x. The reason is the values of x varies from where? 0 to a. So only positive values. So a minus x into cos sx into dx. Okay. Now this is actually what? 2. So root 2 by pi, which is equal to root of 2 by pi. Root of 2 by pi. Now I'm going to integrate using Bernoulli's method of integration. So if I integrate, what you'll get? A minus x, keep a minus x, a minus x, a minus this is x. Okay. Into if you integrate cos sx, what you'll get? Sin sx by s and then minus. If you differentiate a minus x, you'll get minus 1. If you integrate sin sx by s, you'll get what? Minus cos sx by s square. Limit is from close this bracket, close this bracket and close this bracket. Limit is from 0 to a. Okay. So now, actually, this term, the first term is 0 for both upper limit as well as lower limit. The reason is if you substitute x is equal to a, upper limit, because of this term, you will get 0. And because of this term, the lower limit is what? Sin 0 is 0. So that's why this is 0 for both upper limit as well as lower limit. That's why I don't take this one. The next step. So root 2 by pi. So this is 0. Okay, well, this term is 0 for both upper limit as well as lower limit. And then you have what? Minus, minus, minus. So minus. Okay, I'll take minus is outside. Okay, I'll take minus is here. Okay, what is remaining? Cos sx by s square. Limit is from 0 to a. Now substitute the upper limit. You will get minus root 2 by pi. What about the upper limit? Cos SA by S square minus cos 0 1. So 1 by S square. I'll take this minus inside the expression. I'll get root 2 by pi 1 minus cos SA by S square because of this minus. So this is okay. One more step. I will write root 2 by pi. Okay, wow. This is actually 1 minus cos SA is what? 2 sine square SA by 2. So 1 minus cos x formula 2 sine square x by 2 whole divided by s square. So your Fourier transform of f of x, Fourier transform of f of x is equal to 2 into root 2 by pi into sine square SA by 2 whole divided by s square. So I'll take this is a function of s. I'll take this is function of s. Okay, I call this is equation number 1. Okay. Now, okay, now, or you can write one more. Okay, okay, no problem. So you can keep as it is, no problem. Uh, Now, I think here you have what? Reduction part. First part is over. Find the Fourier transform. Reduction part sin t by t whole square. So look at this term. So here also you have the same expression as in the reduction part. So here also I have what? Square, the sin t by t whole square. Here also what? Sin SA by 2s whole square. So that's why we should apply uh, inversion formula to reduce the first part. So by by inversion formula, so what is inversion formula? 1 by root 2 pi minus infinity to plus infinity function of s f of s into e power minus isx into ds is equal to f of x. This is inversion formula. So now 1 by root 2 pi minus infinity to plus infinity. What is your f of s? So this is your f of s. 2 into root 2 by pi. 2 into root 2 by pi sine square SA by 2 by s. Sine square. I'll write sine SA by 2 by s whole square. Okay, I'll write like this whole square into uh, e power I minus isx. E power minus isx is cos sx minus I sine sx into ds is equal to f of x. Okay. So now again root to root gets cancelled. You'll get what? 2 by pi. 2 by pi integral minus infinity plus infinity. So sine SA by 2 by s whole square into cos sx into ds minus I into integral minus infinity to plus infinity sin sa by 2 by s whole square sin sa by 2 by s whole square into sin sx, close the sorry, into ds and then close the bracket, which is equal to what? F of x. So again, I should use the idea of odd function and even function. The numerator is odd, denominator is odd. We know odd into odd is also even. So odd by odd is also even. So totally, this is what? Even function. This is even function. So even into even, even. So this is even. This is what? Odd. So even into odd, you get what? Odd. So the second integral is what? 0. The first integral you can write 2 times 0 to infinity. So 2 into 2, 4. 4 by pi. 4 by pi. Limit is from 0 to infinity. Sin sa by 2 by s whole square. Sin sa by 2 by s whole square into cos sx into ds which is equal to, well, the second integral is 0, which is equal to f of x. Now I am going to write what is f of x. So f of x is uh, a minus mod x. Okay, well, if mod x is what? Less than a. If mod x is less than a and is equal to 0 if mod x is greater than a greater than 0. Greater than a greater than 0. So a is greater than 0. So actually, so you can see where I am introducing, where I am writing f of x. So I don't write here f of x. Just write only I write here f of x, but I don't write the whole thing. So if you write the whole thing here, so you should write here, here, and here. 3 places you need to write. Okay, wow. And then fourth place is also you need to write. So actually my idea is the next step I am going to substitute the values of x. So that's why I am writing f of x here. So depending upon where you are going to substitute the values of x, so previous step write what is f of x in the right hand side. That is enough. So now look at again the deduction part. The deduction part only I have sine terms. I don't have what? Cos term, this term. So make it this is 1. So how to make it this is 1? I want to substitute here, put x is equal to what? 0. So x is equal to 0 is lies in this interval because mod x is less than a means what? Minus a less than x less than 0. So that's why x is equal to 0 lies in this interval. So 4 by pi 4 by pi integral 0 to infinity sine sa by 2 by s whole square into cos 0 1 into ds. So this is equal to what? A minus mod x, but x is equal to 0, you get a. Okay, wow. Now put SA by 2 is equal to t. So then we get integral 0 to infinity. Okay, wow. There is no change in the limits because s is equal to 0, not t equal to 0. S is equal to infinity means t equal to infinity. Sine t by s is equal to 2t by a. 2t by a into ds. ds is equal to uh, 2 into dt by a, which is equal to a. Here I missed what? Square. Okay. So now I'll write in the next page. Okay, sine t by t whole square integral 0 to infinity sine t by t whole square. So sine t by t whole square. Uh, and here you have what? 4.
4 by 5.
Yes. Any mistake, ma? Any mistake?
4 by 5 in the previous line, sir.
Okay, ma. Thank you, ma. 4 by pi. Yes, thank you. 4 by pi misspelled. 4 by pi. The next step, I should write this 4 by pi is also here. Okay, wow. Sine t by t whole square. And then this a is going to the numerator. A is going to the numerator means a square. A square I'll write here because it is constant. And this is what? 2 square is what? 1 by 4. So I'll write 1 by 4 here. Okay, I'll write here 1 by 4. Okay, and then 2 into dt, 2 into dt, which is equal to, I'll write this a here, a square, a square. So what we need, 4 gets cancelled, integral 0 to infinity sine t by t whole square. Okay, off. So a square gets cancelled into dt. The final answer is what? Pi will go that side. Pi by this 2 will come here. So pi by 2 is the final answer. So I call this is equation number 2. So first reduction part is over. Second reduction. The second reduction, look at again this function f of s and the second reduction. So the second reduction we have power 4, but here in f of s we have what? Power square. If I square this one, then only I will get what? This integrand means I need to apply Parseval's identity. So now by Parseval's identity, again I will just write what is Parseval's identity. Integral minus infinity to plus infinity modulus of f of s whole square into ds, which is equal to minus infinity to plus infinity modulus of f of x whole square into dx. Okay, wow. Now, so which is equal to minus infinity to plus infinity f of s whole square. What is f of s whole square means? So if I square this one, so 2 square is 4. So under the root of a square we get 2. So 4 into 2, 8. 8 by pi. So 8 by pi, I'll write here 8 by pi. 8 by pi. And then what is remaining? Still sine SA by 2 by S whole power 4. Because I'm squaring. Sine SA by 2, SA by 2 by S whole power 4. Whole power 4 into ds. So which is equal to, again you need to divide the whole interval, because here f of x, you need to divide the whole interval into 3 parts as I told in the first slide. So minus infinity to minus a to plus a to infinity. The first and last are what? 0. The second integral is what? Minus a to plus a, minus a to plus a. What is your f of x? A minus mod x, a minus mod x whole square into dx, because of here we have square. Now, just I'm going to simplify first to the right hand side, because mod x is an even function. So a minus mod x is an even function. So you can write twice what? 0 to a, which is equal to 2 times right hand side, 0 to a. So you should write a minus mod x again, but the values of x are positive. Mod x is equal to x in the interval 0 to a, but whole square into what? Dx. Now, now I'm going to integrate. So you can apply a minus b whole square formula, a square plus b square minus 2ab, and then you can integrate. But now I'm going to do directly a minus x whole cube 2 plus 1, 3 by 3. And if you differentiate a minus x with respect to x, you'll get what? Minus 1. So the limit is what? 0 to a. So 2 by minus 2 by 3, minus 2 by 3. If you substitute the upper limit for x is equal to a, upper limit is 0, minus x is equal to 0 means you'll get what? A cube. So you will get 2 by 3 a cube. So this is the right hand side. Left hand side, 8 by pi. So actually this is an again what? Even odd function. Odd. This is also odd. Odd by odd is what? Even function. So then you can write this is what? 2 times 0 to infinity. So 2 into 8, okay, 8 by pi, 8 by pi, 2 times integral what? 0 to infinity, 0 to infinity, sine SA by 2 by S whole power 4. Sine SA by 2 by S whole power 4 into ds. Okay. So now I need only this integral. Okay. So integral, I'll write in the next page. Integral 0 to infinity. Integral 0 to infinity sine SA by 2 by S whole power 4. Sine SA by 2 by S whole power 4 into ds, which is equal to this is what? 2 gets cancelled. You can cancel 2 into pi by 24 into a cube. Pi by 24 into a cube. So now here I need a t. Actually, in the deduction part you can see. So that's why I'll take put SA by 2 is equal to SA by 2 is equal to some t. Okay, so now the integral is what? 0 to infinity sine SA by 2 is what? T by S is what? 2t by a whole power 4 into ds. ds is what? 2 dt by a, which is equal to pi by 24 a cube. Okay, so this is actually what here we have a power 4 that is going to the numerator. A power 4 by 2 power 4 is what? 16 integral 0 to infinity sin t by t remaining you have. Okay, whole power 4. Okay, this is 2 into dt. Okay, or you can write dt pi by 24 into 2, 48, 48 a into a cube a power 4. So a power 4 gets cancelled. So 16 by 48, that is 1 by 3. So pi by 3. So the value of this integral is integral 0 to infinity sin t by t whole power 4 into dt, which is equal to pi by 4. So this is the final answer. I think we solved one problem completely for this problem. Okay. Okay. Now we will discuss one more problem. Find the Fourier transform of. Next problem is find the Fourier transform of find the Fourier transform of 1 by root mod x. Root mod x. Okay. So solution. So Fourier transform of 1 by root mod x. So we know that mod x is an even function. So using that concept only we are going to solve 1 by root 2 by pi minus infinity to plus infinity. Okay, f of x is what? 1 by root mod x into e power isx into dx. So which is equal to 1 by root 2 pi minus infinity to plus infinity 1 by root mod x. So e power isx we can write what? Cos sx plus I sin sx. I sin sx into dx. So again, we should divide the whole integral into two parts. I'll write in the next slide. 1 by root 2 pi minus infinity to plus infinity 1 by root of mod x into cos sx into dx. Plus I into integral minus infinity to plus infinity 1 by root of mod x into sin sx into dx. Sx into dx. So again, this is a even function. This is even. So even into even, even. This is even. This is odd. So even into odd, odd. The second integral is 0. The first integral you can write what? 2 times. So 1 by root 2 pi. 2 times integral what? 0 to infinity. So in this interval, because the x is positive, that's why I don't want to write mod x here. Instead of mod x, I'll write what? Just x into cos sx into dx. Okay. So now we have, okay. So this is nothing but root 2 by pi, root 2 by pi, 0 to infinity, 0 to infinity. So here I'm going to use some idea here. Instead of if I keep like this, the integration is a little bit difficult. You cannot integrate easily. So that's why I'm going to write this is real part of e power minus isx by root x into dx. So what is e power minus isx? Cos sx minus I sin x. Real part means what? Sin cos sx. So you may ask, sir, why we need to put here minus? If I put plus also, you'll get the same thing. Yes, but if I put minus, then I can use gamma function. So that's why I'll put here instead of plus, I will put here minus. The next step, I'll take the real parts outside the integral. So you can write real part of 1 by root 2 pi limit integral 0 to infinity 0 to infinity e power minus isx by root x into dx. Okay. Now I am going to give substitution isx is equal to some t. Put isx is equal to some t. So now, okay, real part of 1 by root 2 pi. So now we x is equal to 0, we will put x equal to 0 means t equal to 0. X is equal to infinity means t is infinity. There is no change in the limits. E power minus isx is what? T root of x. X is equal to what? T by is. Okay, x is equal to t by is. T by is. And then dx. Dx is what? dt by is. Okay, so now which is equal to real part of 1 by root 2 pi. Okay, root 2 pi. This I is also constant. This S is also constant because you are going to integrate with respect to what? T 1 by is. Similarly, this root is, okay, I'll write here. Okay, root is also outside the integral. What is remaining? 0 to infinity. Uh, here you have what? E power minus t. Here denominator what? Root t. Okay, so I'll write e power minus t divided by what? Root t. And instead of writing divided by root t, I'll write t power what? Minus half into dt. Okay. So now this is equal to, I'll write in the next slide. Real part of 1 by root 2 pi 1 by root 2 pi. So if I cancel this, we'll get what? 1 by root is. 1 by root is. Okay, 1 by root is. Integral. Okay, so what is, okay, I'll write integral 0 to infinity e power minus t into t power minus half. E power minus t into t power minus 1 by 2 into dt. Now, I think the first semester you studied gamma function. Gamma of n equal to integral 0 to infinity e power minus x into x power n minus 1 into dx. This is the definition of gamma function. If I substitute n equal to half, what you will get? Gamma of half equal to integral 0 to infinity e power minus x, okay, x power what? Minus 1 by 2 into dx. So instead of x, here have what? T. So the value of this integral is gamma of half. Real part of 1 by root 2 pi. I will write this 1 by t power half. T power half means the numerator, sorry, I power half means the numerator, this is what? I power minus half by root s. And the value of this integral is what? Gamma of half. So gamma of half is, we know that, root pi. So real part of 1 by root 2 pi. And the numerator you have I. So I you can write cos pi by 2 plus I sin pi by 2. Sin pi by 2. So because cos pi by 2 0, sin pi by 2 1, so you'll get I. Whole power what? Whole power minus 1 by 2 into gamma of half is what? Root pi. Gamma of half equal to root pi divided by root s. So here root pi gets cancelled. So I'll write one more step here, which is equal to real part of 1 by root 2 pi. Apply De Moivre's theorem. We'll get cos pi by 4 cos pi by 4. I think here minus 1 by 2, we are getting minus 1 by 2 or plus 1 by 2. Okay, minus 1 by 2. Or check it. Yes, minus 1 by 2 only I have. Yes. So cos pi by 4. Okay, cos pi by 4 minus cos theta plus I sin theta whole power minus n. Okay, wow. So cos of minus pi by 4 is what? Cos of minus pi by 4 is cos pi by 4. And then here what? Sin of minus pi by 4 is, sin of minus pi by 4 is minus sin pi by 4. Divided by root s. Divided by root s. So into what? Root pi. Okay, I think we can cancel this root pi already. Okay, I forgot it. This is actually root s. Root s I will write little bit here. Okay, root s. Okay. Now the next step, cos pi by 4 is what? 1 by root 2 minus I. Sin pi by 4 is what? 1 by root 2. I'll write in the next slide. So which is equal to real part of root pi gets cancelled. So 1 by root 2 into cos pi by 4 minus I sin pi by 4. So cos pi by 4 is what? 1 by root 2 minus I into sin pi by 4 is 1 by root 2 by root s. But here we need only the real part. So that's why. Okay. By root 2. Mistake பண்ணிட்டு மாதிரி தெரியுது. think root to root gets cancel. I need to cancel ஆகணும். Yes, here I wrote what? Root 2 by pi. The next step, what I wrote here? 1 by root 2 pi. So that is a mistake. Okay, so I should write what here? Here, because I don't get the answer. Okay, that's why I'm checking here. So root of 2 by pi. The remaining thing is I think correct. Similarly here what? Root of 2 by pi. So here also root of 2 by pi. Here root 2 by pi. Mistake here. Root 2 by pi. Here also root 2 by pi. Okay. So now what is the next slide? Okay. Yes. So here, yes. Previous slide, root pi gets cancelled. In the numerator I have what? Root 2. In the numerator I have root 2. So which is equal to, so if I multiply by root 2, okay, you'll get what? Real part of 1 minus I by root s. So I need only the real part. So that's why the final answer is 1 by root s. So this is the final answer. 1 by root s. This is the Fourier transform of 1 by root of what? Mod x. Root of mod x is equal to 1 by root s. So, okay, I'll check the time. So nearly 8:05. Okay, so we'll stop here. The next problem is actually self-reciprocal problem. Okay, okay, I will do it now. The problem is I will finish it now. Maximum I'll take 10 to 15 minutes. So what do you mean by self-reciprocal? First, self-reciprocal. So what is the meaning of self-reciprocal? Sometimes the definition may be asked if a transformation the transformation of a function f of x is equal to f of s, is equal to f of s, then the function f of x is called self-reciprocal. Self-reciprocal. Okay. So now the problem is find the Fourier transform of find the Fourier transform of e power minus a square x square where a is greater than 0. Hence, Hence deduce that, or hence show that, hence show that e power minus x square by 2, e power minus x square by 2 is self-reciprocal, is self-reciprocal e power minus x square by 2, e power minus x square by 2 is self-reciprocal under Fourier transform. Under Fourier transform. Okay. So first we should write again the definition of Fourier transform. Fourier transform of f of x. So what is here f of x? E power minus a square x square, e power minus a square x square, which is equal to 1 by root 2 pi minus infinity to plus infinity e power minus a square x square into e power isx into dx. Okay, so this is the definition. The next step I'm going to write. I'll write in the next slide. 1 by root 2 pi minus infinity to plus infinity. So I'll take minus common. If I take minus common, we'll get what? E power minus or minus of e power minus of, sorry, e power minus of a square x square minus isx into dx. Okay. So now, so here I'm going to do some small work here. So we know that a minus b whole square, which is equal to what? A square minus 2ab plus b square. So this implies from this a square minus 2ab is what? A square minus 2ab equal to a minus b whole square minus b square. Whole square minus b square. Okay. So now here I'll take a equal to ax and 2ab equal to isx. Okay, so this implies 2 into what is a? Ax. B I'll keep as it is equal to isx. So xx gets cancelled. From this, what is b? B equal to is by a. So this is your b. Okay, so this is your a. Is by 2a or is by 2a. So xx gets cancelled now. Okay. So this is your b. Okay. Now, uh, instead of I'll take this is okay. Next slide also I'm going to do some work. Okay. Next slide also I'm going to do some small work. Okay. So ax whole square minus isx. I'll write ax whole square minus ISX. AX whole square minus ISX is equal to, actually this is of the form A square minus 2AB. Uh, please write A square minus 2AB. AX square minus, okay, yes, A square minus 2AB. Yes. So using this identity, A square minus 2AB, okay, sorry. So this is A square because A equal to what? AX. So instead of A, I'm going to substitute here what? AX. So AX whole square minus 2AB. So otherwise I will write again this one. Okay, so I'll write again this identity and then I'll substitute. What is identity? A square minus 2AB, since A square minus 2AB equal to what? A minus B whole square minus B square. So we know we have what? A equal to what? AX. So AX whole square minus 2 into 2AB is what? 2AB I took what? ISX. Okay, or 2AB is what? ISX. ISX, which is equal to A minus B. What is A? A is AX, B is what? IS by 2A. AX minus IS by 2A whole square minus again B. What is your B? You can see here B is what? IS by 2A. IS by 2A whole square. So this is equal to, okay, now look at this function now. So instead of A square x square minus ISX, yes, okay, this is what? A square x square minus ISX, I am going to replace by this quantity. So I call this is equation number 1. 1 implies equal to 1 by root 2 pi root 2 pi minus infinity to plus infinity minus infinity to plus infinity e power minus, so instead of the left hand side a square x square minus isx, I am going to replace by this quantity ax minus is by 2a whole square minus is by 2a whole square and close this bracket and then into what? Into dx. Dx I'll write here. Okay. Now this is equal to 1 by root 2 pi e power, actually yes, this one I square is what? Minus 1. So minus, here minus. So totally 3 minus. So that's why what? E power minus s square by 4a square is independent of x. So that's why I'll write outside the integral. Now remaining you have what? Minus infinity to plus infinity e power minus ax minus is by 2a whole square into dx. So okay. Now next step I am going to substitute ax minus is by 2a equal to some t. So before this, so we know that okay, we know that okay. So better to substitute first a t and then we'll do. Next step, put put as minus is by 2a ax minus is by 2a equal to some t. So 1 by root 2 pi. 1 by root 2 pi. Limit is e into what? E power minus s square by 4a square into integral minus infinity to plus infinity. This is what? E power minus, this is t, so e power minus t square, e power minus t square. Okay, and then into what? D x, not dx, but dx is equal to what? Sorry, dx is equal to dx is equal to what? dt by a. Dx is equal to dt by a. Okay, now this is equal to 1 by root 2 pi into 1 by a by is constant e power minus s square by 4a square integral minus infinity to plus infinity, okay, e power minus t square into dt. Now I'm going to substitute put t square equal to some u. Okay, so I'm going to evaluate this integral separately. So if I do separately, what we will get? So integral. So for this integral, t square equal to what? T. Sorry, u. Then you'll get minus. Okay, before this, we'll use even function idea, and then you can do. So we know that e power minus t square is an even function. So that's why 1 by a into 1 by root 2 pi into what? E power minus s square by 4a square 4a square into 2 times 0 to infinity e power minus t square dt, because since we know that e power t square is an even function. So here 2 இருக்கு, இங்க root 2 இருக்கு, it gets cancelled. You can write this is equal to 1 by a root 2 by pi into e power minus s square by e power minus s square by 4a square, and then integral 0 to infinity 0 to infinity e power minus t square into dt. So now I'm going to do this work separately, and then I'm going to substitute that. So in this integral, put t square equal to some u. So now this integral is equal to integral 0 to infinity e power what? Minus u into dt. Dt is what? Actually, this implies 2t into dt equal to what? 2t into dt equal to du. So dt equal to what? Du by 2 into t. But t equal to what? Root u. Okay, wow. So now this integral is equal to 1 by 2 0 to infinity e power minus u into u power what? Minus half into du. So again, by definition of gamma function, this is nothing but gamma of half. So which is equal to 1 by 2 into gamma of half is root pi. So and hence the value of this integral is 1 by 2 into root pi. So 1 by a into root 2 by pi into e power minus s square by 4a square into 1 by 2 into what? Root pi. So root pi gets cancelled. Root pi gets cancelled. Now Fourier transform of uh, e power minus a square x square is equal to 1 by a into root 2 into e power minus x square by 4a square. The first part is over. What is the first part? Find the Fourier transform of e power minus a square x square. And then we need to show that e power minus x square by 2 is self-reciprocal under the Fourier transform. So we need to check when we will get e power minus x square by 2. So here I am going to put a equal to 1 by root 2. I put both left hand side as well as right hand side. If I 1 by root 2, then you will get a square is what? 1 by 2. So you'll get what? Minus x square by 2 in the left hand side. So that's why I'm choosing a equal to what? 1 by root 2. So Fourier transform of e power minus x square by 2 x square by 2 is equal to, so here what? 1 by root 2 na 1 by a is what? 1 by root 2 into root 2 okay, e power minus x square by 4 a square. A square means what? A equal to 1 by root 9, a square is 1 by 2. So left hand side is what? Fourier transform of e power minus x square by 2. So root gets cancelled. You get e power minus s square by 2. So this implies, by definition of self-reciprocal, which I gave before starting this problem, we say that hence e power minus x square by 2 e power minus x square by 2 is self-reciprocal under Fourier transform. Self-reciprocal under Fourier transform. So I'll give a practice problem to you. So the practice problem is the solution is available in the biology book. Suppose if you don't get the answer, you can refer biology book. So okay, actually the question is show that e power minus x square by 2 is self-reciprocal under with respect to Fourier transform. With respect to Fourier transform. Or the same question may be asked like this: show that the Fourier transform of e power minus x square by 2 e power minus x square by 2 is e power minus s square by 2. So the solution is very similar to the previous problem. That's why I gave us a practice problem. Okay, so try. Suppose you don't get the answer, please refer biology book. Okay, I'll stop today's lecture. And then we will discuss the remaining problem tomorrow. Okay, so thank you.
Thank you, sir.
Okay.